when you have followed my channel, you will perhaps know that I was busy with the sweep generator via which we can make coils, the properties of radio coils, visible on the oscilloscope. And then I mean the bandwidth, etc., etc. Want to refer to the earlier video. Say we need a sawtooth wave on the scope that moves from this part to this part or the other way, and then we can see the bandwidth. I tested a more or less common circuit that I've used always during, say, the past 30 years, and I could not get it working. And well, that's more or less one of the most important things when we are working with hobby radio circuits or audio circuits, etc., etc. It doesn't want to work. Sometimes, not always anyway. But this is the circuit that I want to demonstrate. Shortwave radio variable frequency oscillator with a field effect transistor, and here is that circuit in practice. And I tested many of the FETs that I had in store. There were many that did not want to work in this circuit, but anyway, could be that they were too old or whatever. Anyway, the BF256B worked and the BF245 worked, and when you want to test them, I will give the link in the description to a FET, small signal FET, field effect transistor tester. Anyway, so this is what it is and what it was also in the past. And here is say the key thing of this circuit, that is the so-called capacitive voltage divider. And there is one capacitor that goes from the gate, not indicated here, but anyway, from the gate to the source, and from the source to the ground. And I found, but I'm not absolutely sure, that this unit that I used to solder everything in has damaged my field effect transistors. Not completely sure, but anyway, I'm not going to use it any longer. There is here inside a direct voltage supply to the here the soldering iron. Perhaps high voltage is leaking, but when I say touched here the outside of this thing with a neon tube, there was no light on the neon tube, and that means in general that there is no high voltage here. Anyway, I think it damaged my field effect transistors, but anyway, and of course we know when you want to do serious experiments, buy a good quality soldering station where, say, the mains is isolated from the secondary winding that supplies the soldering iron. But this is also, say, classical soldering iron connected here to my mains, 230 volt, 50 Hertz anyway, and this works nice. I did not have the problems with this soldering iron. Another thing was that the 470 microhenry coil here, and that is this one here, perhaps you can see it, burned out during all my experiments, and that is extremely strange. So they burned out, and when there is no coil here, the oscillator doesn't work, and perhaps these coils cannot handle a lot of current. And when I talk about a lot of current, I'm talking in the order of 1 milliampere or perhaps 5 milliampere or so. So best advice, wind this coil yourself. It has to be approximately 600 windings on, say, a plastic tube of 3 millimeter in diameter. No ferrite inside. 600 windings works okay. 400 windings also works okay. And of course you need this type of wire here, a kind of ape hair wire. You can buy it or find it perhaps in old transformers, etc., etc. So many problems during the past day. Had not expected it at all. Say, all these problems came together as if I were, say, 15 years old in the past, in the 1970s, when I did my first radio experiments and audio experiments. But anyway, so that are all the things that can happen when you have electronics as hobby. So let's finally look at how it all worked out. We have now a coil here, and the good thing of the circuit is that when the coil has a too low quality, the oscillator doesn't want to start, or starts with a very low output amplitude here, via that 3 picofarad capacitor, etc., etc. But anyway, we are now on 12.2 megahertz with this coil, and this coil has quite a good quality factor. PVC tube, wire, plastic isolated wire, etc., etc. And here we have the field effect transistor that does the job now. Gate, source, drain, etc., etc. Output cap is here, somewhere here anyway. So it works nice. And let me show what happens when we stick into that coil a ferrite rod. Of course, the frequency will go down. Completely logical. Want to refer to many earlier videos that I did on YouTube. So stick that ferrite rod in. Frequency goes down to, say, 6.2 megahertz. Take that rod out and we are on 12.2 megahertz. So, and here the waveform is pure, and here on that lower frequency the waveform is not very pure, but anyway we can switch here that 100 picofarad capacitor out and in. So let's see what happens when we do that. So here we have that 100 picofarad capacitor switched in. Waveform is good, but at the same time we are suddenly on 4.2 megahertz. Anyway, so let me take that rod out again. And now we are on 8.9 megahertz. Stick it in again. 4.2 megahertz. Anyway, so it is a properly working radio oscillator, useful for serious shortwave experiments, etc., etc. It was a circuit that was always very reliable anyway. Still reliable now. And here is that schematic again, and thanks for watching. And of course, say, it's a free running oscillator, so everything that happens here in terms of, say, earth and effect will have an effect on the frequency. So I want to move my hand now over that oscillator. Let's see what happens. So you see that frequency change a little bit. That means that when you want to use this, the whole construction must be sturdy. And there's also, of course, a temperature effect. So here are the connections of the BF256B and the obsolete BF245A, B or C. And this is in fact the transistor, the field effect transistor that works best and always, though it is obsolete. Perhaps you can buy it somewhere still now on the World Wide Web, etc., etc. But this is not obsolete. Thanks for watching again. Pan over somewhat and we'll stop the video.